Hello everyone, in this video we are going to discuss Theorem 6.3 from the chapter 6 Triangles class 10 Max. See, according to this theorem, if in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio or in the same proportion, and hence the two triangles are similar. And this criterion is referred to as the AAA criterion, that is angle criterion of similarity of two triangles. Let us see the proof of this theorem. See, for that I am just considering two triangles ABC and another triangle DEF, such that angle A is equal to angle D. Okay, angle A is equal to angle D. And angle B is equal to angle E. Angle B is equal to angle E. Okay, then angle C, this one. Angle C is equal to angle F. Angle F. So we are considering two triangles such that angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. Okay, then we have just considered one dotted line here, okay, which is PQ. And this PQ, this divides this side DE into two, that is DP and PE. And it also divides this side of the triangle DF into two, that is DQ and QF. Okay, such that this DP is equal to AB. Okay, and DQ is equal to AC. That is, we have just considered a dotted line PQ which divides this side DE into two, DP and EP or PE, and this side DF into two, which is DQ and QF. Okay, such that you see, such that this DP is equal to AB and DQ is equal to AC. Okay, so while considering the two triangles, AB is equal to DP. Okay, while considering the two triangles, you see AB is equal to DP. Okay, similarly AC is equal to DQ. Okay, and angle A is equal to angle D. Okay, so here the two sides, okay, one is AB, here DP, DP, then AC and DQ. So here the two sides AB, AC of this triangle and the included angle means angle formed between these two sides, that is angle A of one triangle, it is respectively equal to the other two sides, okay, DP and DQ, and their included angle D. Okay, that is here the two sides and the included angle of one triangle are respectively equal to two sides and the included angle D of another triangle. So, by SAS, that is side angle side congruent rule. Okay, we are considering SAS congruent rule, that is side angle side congruent rule. According to this, we can say that these two triangles are congruent. That is, triangle ABC is congruent to, this symbol stands for congruent to. So, it is congruent to this triangle DPQ. Okay, DPQ. Okay, because here the two sides and the included angle of one triangle are respectively equal to the two sides and the included angle of another triangle. So, by side angle side congruent rule, SAS congruent rule, we can say that these two triangles, that is triangle ABC and triangle DPQ, this triangle, they are congruent. Okay. Now, by CPCT, that is corresponding parts of the congruent triangles, we can write angle B is equal to angle P. Okay, angle B is equal to angle P by CPCT, that is corresponding parts of the congruent triangles. We can write like this: angle B will be equal to this angle P. Okay, that is when two triangles are congruent, their corresponding parts are equal and the length of their sides, that is the length of their sides and angles. So, angle B will be equal to angle P. Okay, and it is given that angle B is equal to angle E. Okay, so by comparing these two, we can write angle P is equal to angle E. Okay, now in geometry, a transversal line in geometry, a transversal line is a line that intersects two lines at distinct points in a plane. Okay, the straight line that intersects the two or more lines is called a transversal. So here you see this line PE, it is a transversal line. See this line PE, it is transversal. That is, this transversal line PE intersects the two lines PQ and EF. No, that is, here we have a line PQ, I am just extending it like this, and here we have another line EF, I am just extending it like this. So you see this line PE, this is a transversal line here, and this intersects the other two lines PQ and EF. See, when a transversal line intersects the two lines, it creates pairs of corresponding angles, alternate interior angles and alternate exterior angles. So for lines PQ and EF, PE is transversal. And you see, angle P is equal to angle E. Angle P is equal to angle E. Okay, these two, I mean angle P and angle E, these two are actually their corresponding angles. And corresponding angles are equal. Corresponding angles are equal. Angle P is equal to angle E. This implies that PQ is parallel to EF. PQ is parallel to EF. Now, from basic proportionality theorem, which is theorem 6.1, which we have discussed in our previous video, we have, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So here you see PQ is parallel to EF. Okay, PQ is parallel to EF. And this PQ line intersects, it actually intersects on this line DE as well as on this side DF. So from basic proportionality theorem, we can write dP by PE is equal to dQ by QF. Okay, from basic proportionality theorem, we can write dP by PE is equal to dQ by dQ by QF. Okay. Now, let us inverse this equation. That is, let us just take the reciprocal of this equation. So, this becomes PE by dP is equal to QF by dQ. Okay, numerator becomes the denominator and denominator becomes the numerator. Now, what I am doing is, I am going to add plus 1 to both the sides of this equation. When we add plus 1 to both the sides of this equation, it actually becomes PE by dP plus 1 is equal to QF by dQ plus 1. Okay, now I am just doing the cross multiplication. 1 means 1 by 1, here also 1 by 1. PE into 1 is PE plus dP into 1 dP divided by dP into 1 dP is equal to QF into 1, which is QF, plus dQ into 1 dQ divided by dQ into 1 dQ. Okay, now you see this PE plus DP and QF plus DQ are actually what? See, in this figure, PE plus DP, this is actually equal to this side DE. Okay, and DQ plus QF, that is actually equal to this side DF. Okay, and it is also given that DP is equal to AB and DQ is equal to AC. We are going to apply that to our equation. So PE plus DP, that is equal to DE divided by DP is equal to AB. Okay, this is equal to QF plus DQ, which is equal to DF. Okay, then DQ. DQ is equal to AC, no? Okay, now let us just inverse this equation, that is taking the reciprocal. Numerator becomes the denominator and denominator becomes the numerator. So we can write AB by DE is equal to AC by DF. Okay, similarly, this result is important. Similarly, we can also prove that AB by DE is equal to BC by EF. We can prove this as well in the same way. So while you are comparing these two, see AB by DE, this is equal to AC by DF, and this AB by DE, this is also equal to BC by EF. Okay, that is, the sides of the both triangles are in the same ratio or in the same proportion. So we can say that triangle ABC is similar to triangle DEF. Okay, see, this symbol stands for similar to. Now, let us just discuss a remark which is given in your textbook, which is AAA similarity criterion for true triangles. That is, if two triangles, if two angles of a triangle are respectively equal to two angles of another triangle, then by the triangle sum property of a triangle, their third angles will also be equal. That is, if angle A is equal to angle D and if angle B is equal to angle E, then their third angles, angle C, that will be equal to the third angle here, angle F. Therefore, AAA criterion or similarity criterion can also be stated as, if two angles of one triangle are respectively equal to the two angles of another triangle, then the two triangles are similar. That is what AAA similarity criterion for two triangles states. So in this video, we have discussed about the theorem 6.3. We have already discussed about the theorem 6.1 and 6.2 in our previous videos. Everything is available in the playlist. I hope it is clear to you. Thank you.